Then the next one, convert 134.4 kilometers per hour to miles per second. And then I gave you a hint here about kilometers and miles. So I'm going to take 134.4 kilometers, and then I'm going to write the 1 hour directly underneath. Never write a slash. Then I'm going to take a look at where I need to go. Well, I need to go to miles per second. So way over here, I'm going to write miles per second. So I need to convert kilometers to miles and hours to seconds. Eeny, meeny, miny, mo. Pick your favorite unit. Convert that one first. I'm going to get rid of hours first, and I'm going to convert to seconds since we just did that. So in order to get rid of hours, I'm going to put hours up here, and then I'm going to put minute down here, and there goes hours. So we know that 1 hour is 60 minutes. And then I have minutes, which isn't good. I don't want minutes. I want to get rid of minutes, so I'm going to put it up here, and I'm going to put seconds down here. So minutes will cancel, and I'm ending up with seconds. Now circle the unit that you're looking for, so then you know you're done with that. You never want to cancel anything out again that's on the bottom that deals with time. So we know that 1 minute is 60 seconds. If I was to stop my problem right here, I'd end up with kilometers per second. That's not what I want. I want miles per second, so I have to get rid of kilometers. So I'm going to take kilometers, which is on top of my fraction, and I'm going to put it all the way over here and put it on the bottom. Now kilometers will cancel. Ignore all the stuff in between. Look at kilometers, one on top, one is on the bottom, so you know mathematically they're going to cancel out. Then we're going to go from kilometers to miles since we have a direct conversion right here. 1 mile is 1.61 kilometers. So now I'm going to be left with miles on top, seconds on the bottom, which is exactly what I want. Then to do the math, you multiply by anything on top, divide by anything on the bottom, and you get 0.02319 miles per second. Okay, so the next question asks about 37 eggs. How much would 37 eggs cost if 1 dozen are sold for $1.99? That's a conversion factor. 1 dozen and $1.99 together is a conversion factor. And you're starting with 37 eggs because that's what you're given in the problem. So start with 37 eggs, and then without thinking, you're going to write the word eggs down here because that's what you ultimately want to get rid of. So you want to cancel the word eggs out. Now, what do you know about eggs? Well, you know that if you have 1 dozen, you're going to have a certain price. So you've got 12 eggs is 1 dozen. Actually, I should have just written the word dozen up there. 12 eggs is 1 dozen, and that'll get rid of the word eggs for you, and then you cancel out dozen, and you put 1 dozen down here, and you know that 1 dozen is equal to $1.99. And then you multiply across the top, and you divide by anything that's on the bottom. So 37 times 1 divided by 12 times $1.99 divided by 1, which you don't need to do. And your answer is $6.14. Oops, $6.14. Okay, density. Now there's 2 ways you could do density. You could do it the old-fashioned way you guys learned, where it's D equals mass divided by volume. Now this problem is pretty straightforward because that's the only way you're going to solve for density. Later on we're going to see it as a conversion factor, and I'll solve the problem 2 ways. But density equals mass divided by volume. So you're going to put the mass on top, 83.4 grams, keep your units there. And then down on the bottom you're going to put your volume, 45.65 milliliters. So we want to see the relationship between grams per milliliters. Now, we want to divide through, and the whole reason that you have to use this equation in the first place is we want to divide through so we can get 1 milliliter on the bottom. Then we can make comparisons because we know exactly how much 1 milliliter weighs. So divide these two, and you'll end up with 1.83, and I'm using 3 sig figs because my top number's got only 3. The bottom one has more, it has 4, so I have to use least. So 1.83 grams per, draw a straight line, 1 milliliter. So now I can compare this to other things as long as I have 1 milliliter of all those other things. And also remember that 1 milliliter is equal to 1 cubic centimeter. If I had a little box, 1 centimeter by 1 centimeter by 1 centimeter, and I filled it up with something, it would have a volume of 1 mil. Okay? Just keep that in the back of your mind. Alright, letter B. This is the one you could solve using 2 different methods. Over here it gives you the density and also tells you the volume of your sample. I'm sorry, it tells you the mass of your sample because we got grams here, and you have to find the volume. So we're going to start with writing our formula. Density equals mass divided by volume. So we know our density, 3.45 grams per 1 cubic centimeter. And then we know that the mass is 34.4 grams. And I put that on top because the mass is on top. And on the bottom, I'm going to put an x. So you can solve using basic algebra for this. You could just cross multiply if you want. 1 times 34.4, and then 3.45 times x, solve for x. And x will give you 9.97 cubic centimeters. Remember, grams are going to cancel out. We're going to end up with cubic centimeters. The other way you could do this is a ratio, or the way you've probably been doing this in math class. The other way you can do it is using dimensional analysis, which was what we learned here. Start with what you know. Let me draw a line to separate. This is the other way that you should be able to use to solve for this. We know we have, because the problem tells us, 34.4 grams. Without thinking, you put grams on the bottom. We want to solve for volume. We peek over here. We know that volume in this problem is going to be in cubic centimeters, so we write cubic centimeters up there. Grams are going to cancel. We're going to be left with cubic centimeters. So we just have to fill in our numbers. Well, you know that 3.45 grams is equal to 1 cubic centimeter for this particular stuff. So you fill in your numbers. 3.45 grams is equal to 1 cubic centimeter. So you're going to take the top numbers, multiply, divide by whatever's on the bottom, and when you do that, you're going to be left with cubic centimeters. Your answer is 9.97 cubic centimeters. Okay? So this is basic dimensional analysis. This is, I think, a little bit more straightforward than setting it up this way and solving for x, especially when x is on the bottom. Some kids have a hard time with that. You might as well use dimensional analysis. Density is always going to be in the center. It's always your conversion factor, and you always write down whatever you're going to start with, and just make sure density is flipped upside down so the units cancel. And that's it. All right, the last problem, 37 in this section here, is asking you about percent error. How far off are you? So it says, imagine you calculate the density of a substance and it comes out to 3.45 grams per milliliter. After checking the reference book, you realize it should be 3.60 grams per milliliter. Then it says, calculate your percent error using the following formula. You want to find out how much off are you? What percentage of the true value are you off? So here we go. This is a formula you need to know. Percent error equals, and this should be an absolute value signs here, the experimental value minus the accepted value. Figure out the difference between the two, and then divide it by what you should have gotten. So let's work this out. The experimental value is what you measured, the 3.45. And the accepted value is what you should have gotten based on the reference value. So it should have been 3.60. And then you're going to take the absolute value of the difference here. So the difference is, don't worry about the negatives, 0.15. So that's how much you're off, and then you're going to divide it through by what it should have been. Accepted value is 3.60. That's what the reference book says. So 0.15 divided by 3.60, and then don't forget, because you're going to end up with a decimal here, multiply it by 100, because you're going to put it in percents, and you end up with 4.17. And then ask yourself, is that logical? You're looking for the percent error, how much you messed up by. It's a very small percent error, just about 4% error, which makes sense because you're not off by that much. You're only off by 0.15. So you shouldn't have a big percent error. If you did something wrong and you ended up with, let's say, 80% error, that should be a huge red flag, because you look at your numbers and say, well, I'm not really off by 80%. So you want to have a low percent error, and that's good. Okay? And that's it for this math section. Good luck.